All right, create histograms. So this video is going to talk to us about histograms. A histogram is a graphical display of data using bars of different heights. So when we look at this histogram that we have on this slide, it looks like we are figuring out the frequency of different heights of trees. So trees between 100 and 150 centimeters, and whatever sample we have here, it looks like we have about 4 or 5 trees that are between 100 and 150 centimeters. It looks like we have about 30 trees that are 150 to 200 centimeters tall, about 26-ish trees that are 200 to 250 centimeters tall, about 50 trees that are 250 to 300 centimeters tall, and about 11 trees that are 300 to 350 centimeters tall. So when we think about histograms, in this video, we're going to talk about 3 things that we can analyze about the data from a histogram. In our future lessons, in the following Canvas lessons having to do with univariate data, we're going to be talking more about how to calculate these things specifically. But today we're looking just at, when we're looking at a histogram, what can we see? So one of the first things that we can analyze from a histogram is the shape of the data. So the data can either be skewed or it can be symmetrical. When we talk about skewed data, that's data where most of the data is on one side of the graph, and then we have a little bit of a tail. So in this first histogram, most of the data is on the right side of the graph, and then we have a little bit of data on the left side. It's like the data forms a tail on the left. When we have that tail on the left, we call that a skewed left shape. The shape would be skewed left. In the middle, our data is almost perfectly symmetrical. It looks even on both sides. So we would describe the shape of that data as being symmetrical or even on both sides. And then our last graph, it looks like most of the data is kind of on the left and the middle. And then we have a little bit of a tail on the right. So we would call that skewed right data. The shape is skewed right. Another thing that we can look at with histograms is the center, measures of center. So both mean and median are measures of center. Mean is the average of the data, and median is the very middle point of the data. So you all talked about these things in 8th grade. So mean is the average of the data, median is the middle point of the data. In future videos and future lessons, we're going to talk more about how to specifically calculate median and mean. But for today, we're just going to analyze which would be a better measure of center based on the shape of the histogram. So when we have symmetrical data, mean is the best measure of center. Our data is even on both sides. We don't really have any outliers. So a symmetrical histogram, the mean is the best measure of center. When our data is skewed either to the left or the right, the median is the best measure of center, because those outliers or those smaller or larger numbers that aren't really with the rest of the data, that can change what our mean is. It can affect our mean. So median is going to be the best measure of center when our histogram or when our data is skewed. Mean is the best measure of center when our data is symmetrical. Okay, and then our last thing that we're going to talk about today is the spread of the data. So spread of the data refers to the range of the data, and we can calculate this by taking our largest data point and subtracting our smallest data point from that. So in this first graph, it looks like our data is ranging from 21 to 100. So to calculate the range, I'm going to do 100, or my largest data point, minus 21, which is my smallest data point. So my range for that first histogram, or for that first data set, would be 79. The next 2 histograms, my smallest data point is 11, and my largest data point is 100. So the range for both of these would be 89. Again, I'm taking my largest data point and subtracting my smallest data point from it. So range is referring to how spread out the data is. All right, so now we're going to talk about creating histograms using technology. So this website is a great tool to use to create histograms on the computer. So when we click on it, it takes us here. We have a coordinate grid on the right, and then on the left at the top, it says data sets. So we can type in our data here and it will create a histogram on the coordinate grid for us. So using that information, let's do this example together. If you want to pause the video and try this on your own and then come back to see if your data looks like mine, you are more than welcome to do that. So Miss Kirby's math students took a test. Their scores were 29, 100, 45, 75, 78, 82, 75, 78, 79, 85, 90, 82, 75, 90, 82, 75, 89, 90, 93, 78, and 95. Create a histogram to represent this data. So I'm going to come back over here and I'm going to type in all of these data points. So my first score was a 29. I had a 100, 45, 75, 78, 82, 75, 78, 79, 85, 82, 75, 90, 82, 75, 89, 90, 93, 78, and 95, okay? So we can see that nothing is showing up here. That's because my grid is only going over to 11 on my x-axis, so I need to zoom out until we see all of that data. So here we go. So this is what, this is what our histogram would look like for our math test data that was just in the example. So when we look at this, we could figure out the range of the data. So we know that our largest value is 100, and we know that our smallest value is 29. So I could calculate the range by doing 100 minus 29, and that would give me the spread of my data. I can analyze the shape of my data. It looks like I have a little bit of a tail over here, and then most of the data is on this side. So I would say that this data is probably skewed left. And then knowing that it's skewed left, the best measure of center to use would be the median, not the mean. So remember, whenever our data is skewed, we want to think about median as our measure of center instead of mean. If our data is more symmetrical, then we would want to use mean as our measure of center.